This time, we are given with a function 3z to the power of negative 2. And we are tasked to solve for the derivative of the given function at z equals 1 plus I using a definition. Again, our function is f of z is equal to 3z to the power of negative 2, or can be written as 3 over z to the power of positive 2 using the law of negative exponents. To solve for the derivative, to solve the derivative for at the given value, we are going to, of course, first and foremost, find the derivative. But in the previous video, we already had that. This is the second part of that video. That video contained the derivative together with the processes involved in determining the derivative of this given function. If you would like to review that in this playlist, it's just the previous video, okay? Or you will have it here. That video contains all of these discussions, which yielded negative 6 over z cubed, or you could also have it here, negative 6 times z to the power of negative 3. But of course, you would like to stick with this one here with positive exponents. This is now a derivative. We had all of these processes and discussions in that specific video, so I'm not going to repeat that. I'm going to copy this here because this tells us the derivative of the given function. It's negative 6 over z to the power of 3. So as simple as this is, we are just going to identify the value of the derivative at z is equal to 1 plus I. In short, simply substitute here 1 plus I for our answer. Negative 6, and have here 1 plus I cubed. This is the solution to the derivative of the given function at 1 plus I using the derivative we had in the definition. If you also would like to use the derivative using the rules of differentiation, I believe you will still get the same value because you are going to have the same derivative and the same value for your z. Now, this is already okay, but if your professor would like you to simplify that, of course, you can break the solution, not necessarily break, give the appropriate value for your denominator. So that's actually the cube of 1. Take note of that, special products for the cube of a binomial expression, plus 3 times the square of 1. This is not necessarily needed here, but allow me to use this because there might be some items that can be simplified. So we have here I plus 3 times 1 times I squared, and you have here finally plus I cubed. Allow me to continue here and give the other form of the answer. So you have negative 6 all over 1 cubed is 1. You have here plus 3 times 1 squared is 3, so you have 3i. Here you will have plus 3i squared plus I cubed. Take note that I squared is equivalent to negative 1 because your I is equal to the square root of negative 1. That would mean here negative 6 over 1 plus 3i plus 3 times negative 1 as what they call this one, as your I squared is negative 1. Then you have here plus, we know that I cubed is I times I squared, right? And since I squared is actually equivalent to negative 1, so we'll have here negative 1 as well. So hopefully you were able to understand why we're doing this, because we can still simplify the denominator. So you have here negative 6 over 1 plus 3i, that's minus 3 and minus I, which will give us the final answer of negative 6 over, that's negative 2, 1 minus 3. You have here 3i minus I is positive 2i. Okay? Now, take note, we are writing it in a way where we write complex numbers. We start with the real part and then the term with the imaginary unit. But we can still simplify this further because we know this is 2 times negative 3. And your denominator can be factored with 2, negative 1 plus I, which will give us the final answer as you cancel that, equivalent to negative 3 over negative 1 plus I. This is now the value of your given function, value of the derivative of the given function at your value of z equal to 1 plus I. Now, other references would like an answer where the denominator will no longer contain the imaginary unit I. So what we could do here is, of course, continue with this process and multiply this with the conjugate. so that we can simplify the denominator, or the other term for that for radical expression is rationalizing, right? So this one here, you are going to multiply with -1 minus I. Okay, same first term, same second term, but different operation. Okay, so that you can actually simplify it further. Allow me to continue that here. Let me use the red for a colored item here. So you have -3 times -1 minus I. All over your denominator, you can use difference of two squares. The square of -1 minus the square of your I. This would mean this is actually +3 plus 3I all over, you'll have your 1 minus, take note that I squared is the result. And I squared is, again, I don't know if you have, yeah, this one here is already -1. So this is actually 3 plus 3I all over 1 minus -1. And our denominator will no longer contain the imaginary unit I. So you have here the result, which is 3 plus 3I all over 2. 1 plus 1. This is also the equivalent value to this earlier. But earlier, we're not able to simplify that or remove the imaginary unit in the denominator. If we do so, and some professors would like us to do this, so we can have this process here. So basically, this is still their answer to your item here for the derivative of the given function at z equals 1 plus I, regardless of whether we use the derivative determined by the definition in the previous video, or you will be using a rules of differentiation, which I could guarantee you will get the same answer. So this is the result for this item. Thank you very much for watching.